Okay, so let's consider this new situation. I hope you had a look at the previous video and solved the problem of the previous collision. So in this collision, it's a little bit different. Superman is still going at 10 meters per second, and it is still an elastic collision where two objects bounce off each other. But this time, the mass of the ball is a lot larger. So just like before, Superman has a mass of 100 kilograms, but this time the mass of the ball is 1,000 kilograms. And indeed, the ball is actually moving slowly towards Superman. So it has a velocity of -1 meters per second. So the ball is moving to the left and Superman is moving to the right with constant speed. Now, why is there a minus? Well, if you recall, velocity is a vector, and therefore, if it's a vector, it matters which direction it is going in. So if it's going to the left, we will give it a minus, and if it's going to the right, we will give it a plus. Now the question is, what is going to be the speed of the ball after the collision? So I'm going to give you one more piece of information, and that is the speed or the velocity of Superman. In this case, he's going to recoil after the collision. So he's going to be going at -9.6 meters per second. This situation looks a lot like this one. Because the ball has such a large mass, Superman is going to recoil when it hits it. However, the ball is also going to gain a little bit of speed, and the question is, what is going to be the velocity of the ball after the collision? So, try it on your own, pause the video, and give it a try. Okay, you have your answer. Let's see if you got it right. Using the conservation of momentum, we know that the total momentum before the collision and the total momentum after the collision have to be equal. So what we need to do is find all the momenta on the left, all the momenta on the right, and then compare them. And that will lead us to the answer. So let's try that. The momentum of Superman is going to be 100 times 10. So that is going to be 1,000 kilogram meter per second. The momentum on the ball on the other side is going to be 1,000 times -1. So that is -1,000. Again, kilogram meter per second. Now 1,000 minus 1,000 gives us quite simply 0. The momentum of the system is 0. Now let's find the momentum on the right. So on the right, the momentum for Superman is going to be 100, the mass, times 9.6. But be careful, we have a minus here. So in total, it is going to be 960. Again, kilogram meter per second. The momentum of the ball is going to be its mass, 1,000 times the velocity, v. Now v is the unknown or the question, and that is what we need to find out. Now the total momentum on the right is simply the sum of these two momenta. So let's add them up. The total momentum is going to be equal to 960 plus 1,000 times v. Now from the conservation of momentum, we know that whatever number the total momentum is, this p here, has to be equal to the total p on the left. So these two numbers should be the same. So if the left is 0, then this number should be 0. So let's write that equation and try to solve it to get to the answer. So our equation is 0 equals -960 plus 1,000v. In other words, v equals 960 divided by 1,000, or v equals 0.96 meters per second. And that is the answer we were looking for. So the large ball is going to move forward, since v is positive, with a very slow speed, smaller than 1 meter per second.